Hi and welcome to this video on the four transformations: translation, enlargement, rotation and reflection. Firstly, we're going to have a look at enlargement. When we're doing enlargements, we must specify the scale factor and the center of enlargement. So if we take this as the center of enlargement, we draw grid lines, and this is the object we're going to enlarge, this one labeled A. We draw grid lines from the center passing through the points of A. So this one's passing through B, and this one from the center of enlargement passing through C. Then we go the same distance from the center of enlargement as to the point. So we go from here to this new point C dash. So that's the same distance here as here, and the same from the center of enlargement B to the new B point, and then the same distance from the center of enlargement to our new point A dash here. Join these points that we marked off, and this is our enlarged figure B, and this is an enlargement scale factor 2. Here again we've drawn our grid lines from this is the figure we're going to enlarge, so we draw it from there to our center of enlargement, from C through to our center of enlargement, and then from B to our center of enlargement. Once we've drawn our grid lines, we're going to enlarge this by a scale factor of half. So we go down the grid line by the same distance B to B dash as B to the center, and this is a scale factor of a half. Always state the center of enlargement. So here the center of enlargement is the point 0, 0. If we want to find the center of enlargement, say we want to find the center of enlargement of these two figures, draw our grid lines through the same points. So this is the top of the T, through the top of the T, draw a grid line, bottom of the T, bottom of the T, draw a grid line, and when the two grid lines meet, that's our center of enlargement. So the center of enlargement here is 2, 2. Quite a tricky one here. If you want a scale factor which is a minus, often asked in exams because it's a little bit tricky. So what we do here is we draw our grid lines again, but we pass through our center of enlargement and go to the other side. So continue our grid lines to the other side of the center of enlargement. Now if we want a scale factor of minus 2, the distance from our origin to our point X, double that. So this is double the distance from the origin to X to our new point X dash. And the same with W, this distance from W to the center of enlargement, double that distance to get to our new W as we go along the grid line. And this is a scale factor of minus 2. So this object, and gone to this object, minus scale factor of minus 2. Also it resembles a rotation. We'll get onto rotations in a minute, and you'll be able to see that. Reflection. We always have to specify the mirror line in a reflection. So this figure is reflected in this mirror line, which is the y-axis, and this is our reflected figure. If we draw grid lines again from our points which are the same, so from A to A dash, from C to C dash, and then we bisect those lines, that's our mirror line. And this distance from A to the mirror line is the same as the distance from the mirror line to A dash. And this distance from C to C dash is the same as from the mirror line to C dash. So that's very important. So the reflection is an equal distance away. All the points on that object are an equal distance away from the mirror. Here we have a reflection in the x-axis. So this object has been reflected. This distance to the mirror line is the same as this distance to the reflected point, and the same for all the points on the object. So is this a reflection? Looks like it at first glance, looks like a reflection in the x-y axis, but no, when we double check this distance from this point, it's not the same distance. So it's not a reflection, and also the figure is a different shape from the figure that a reflected shape should be. So be very careful. A rotation must specify the angle turned. So this figure has been rotated, and this is the new figure. You have to specify whether the direction of rotation is clockwise or anti-clockwise. So this is clockwise and the other way round is anti-clockwise, and you have to specify the center of rotation. So this distance from the center of rotation, which is here, to this point remains the same when we rotate. So let's try and rotate it. Let's try that. So when we rotate, this distance remains the same. How do we find the center of rotation? This is quite easy. We draw grid lines from our original Q, our point on our original figure, to our rotated Q dash, and then a grid line from our point R to our new point on our rotated figure R dash, and then we bisect those lines. So this is our grid line connecting the 2 points, same points on the figure. This is our grid line connecting our point. Then this is the bisector of that purple grid line, and this is the bisector of the black grid line. And where these grid lines meet, that's the center of rotation. You can use a compass to bisect these grid lines. So how do we find the angle of rotation? So the angle of rotation, we draw a line from the point we're interested in to our center of rotation, then from our center of rotation to our rotated point. So this here is the angle of rotation, and then the direction, this is clockwise. So here again I'm showing how we find the angle of rotation. So this point A, sorry, we're starting at A, and this is our reflected object. Draw lines connecting the points. This is the center of rotation, and this is the angle of rotation. Translation. In a translation, we must specify the vector of translation. The vector of translation is written like this, where the top number specifies whether we go left or right, negative if it's left, positive if it's right, and these are the units on the grid. This is up or down, so positive going up, negative going down, units on the graph. So if we have a look at this figure, we've gone this way, we've gone left, so that's a negative translations, so that's -3, and we've gone down. When we've gone down, that's a negative as well, so we've gone down 6 units, so that's -3, -6 as the vector of translation. So how do we get this vector of translation? Very easily. We draw the path of a point. It'll always be like an L shape. So this is the path of C. It's going down, and then it's going left. So this left is positive, so it's a +4, and down is a -9. So the vector of translation of the object 4, negative 9.